Hello and welcome back to my channel tutorial. Today I am here to discuss about STATCOM, and in this video I will simulate one project, okay, which is related to STATCOM. So before starting this simulation, we should understand a little bit about STATCOM, means a general fundamental idea we should have about the STATCOM. So generally STATCOM is a solid state switching converter which can be useful for delivering or absorbing real as well as reactive power to the grid, okay, while it is fed from a energy source, and this energy source could be a DC power supply, or generally it is a static capacitor. This is the circuit configuration, or you can say typical diagram of a STATCOM. So you can see that we have a static capacitor as a DC energy source, which is connected to the grid through a voltage source converter. Okay, so this voltage source converter is actually known as a static compensator. So how this static compensator works actually? So to understand this fundamental, there is some conditions. Okay, that conditions is very important. Okay, so first condition is that the voltage which is generated by the static compensator, that should be greater than the grid voltage. Okay, then it will delivers reactive power to the grid. If the STATCOM generated voltage is less than the utility grid or grid voltage, then it will absorb reactive power from the grid. And if the STATCOM voltage phase leads uh, utility grid voltage, then it will delivers real power to the grid. And if the ES lags with ET, means utility grid voltage, then it will absorb real power from the grid. Okay, so these are the four fundamental conditions should have in your controller if you want to operate a voltage source converter as a STATCOM. Okay, so this is the basic fundamental we should know while we are simulating a STATCOM compensator. What is the major advantage, okay, of static compensator? That it helps in maintaining system stability during transient events by providing fast acting reactive power compensation. Okay, so in general, mainly we are using STATCOM for supplying and absorbing reactive power. Okay, but in some cases we also use STATCOM as to deliver the real power. So now we will go to the MATLAB. Okay, so open your MATLAB software, and there in the Simulink we will use a special library, that is the Simulink power system special library, and using all the Simulink special library we will create a STATCOM. So let's start the software. So now I will start the simulation. So you can see that my MATLAB is open. I have opened one Simulink window. So before starting the simulation, I will do some setting, okay, so that the things will go very proper. So first thing which I'm going to do is that the model setting. So just click here. You can see here the model setting. So go inside the model setting. You will be able to see the solver. Okay, so solver setting is very important, and it is always desired to use the fixed step discrete solver setting. Okay, so I'm going to choose the type that is fixed step, and the solver setting, any one of this we can choose, but for the time being, okay, I'm going to choose the discrete one. And we have to give the fixed step size. So whenever we are choosing the fixed state type of solver, definitely we have to give the fixed step size. Otherwise, it will take the auto one. Okay, auto one is not recommended if you are going to verify your model in the later stage of time. So it is always recommended to give or choose the fixed step size. So now I'm going to choose fixed step size, that is 1 e power minus 6. Okay, so just apply and do not do anything, just click OK. So now we have to take first of all the thing which is very important, that is power GUI. You know very well why power GUI we are using. So if you still don't know, then I'm going to tell you that whenever we are using Simulink special library blocks, we have to use the power GUI block. Okay, so without using power GUI block, we cannot use the Simulink special library blocks. So now this one I will take for this case, which however I am going to simulate, that is the STATCOM. So I will take it is 1 e power minus 6. Okay, so we can choose the sample time up to 1 e power minus 6 because 1 e power minus 6 is our minimum simulation time step. So here it could be exact equal to the minimum simulation time step or integer multiple of minimum simulation time step. So we can take here 10 also, okay, but now I'm going to take here 1 e power minus 6 only because it will give us a very good result. Okay, so why we are choosing all these things means here 1 e power minus 6 or more than 1 e power minus 6. So that is a different story, and I will cover that story in the later videos. So always I'm going to tell you that please stay connected with my channel. So thank you for subscribing. Still you have not subscribed, then please subscribe my channel. Give me motivation. Okay, so let's start. So what is the basic idea behind STATCOM? So already we have seen, right? So at first we will take one three-phase source. So double click on the window, okay, and write three-phase source. So this one you can see three-phase source, okay. So here it is, right? So double click on it, and this voltage you take for 15 volt, and this one 50 hertz, and this internal resistance I will take 1 e power minus 6. Internal inductance I will take 1 e power minus 6 also, and this one 415 volt. This is the base voltage. Okay, so just apply and click OK. Now I want to measure the voltage and current. Okay, so for that we have VI measurement block. Okay, so this is the VI measurement block. So choose this one and double click on it. Okay, so what voltage we can measure? Using this we can measure phase to phase and phase to line. So here I am going to measure the phase to ground voltage, and also I want to have this label, okay, the ABC. Similarly, current also we want to measure, and this is the label I want to use here, IABC for the current. So apply and click OK. Now connect it. Okay, so easily we can connect. Now I want to use one load, so just type load. Okay, parallel load I want to take. Okay, three-phase parallel load I will take. So here you can see three-phase parallel load, this one. Okay, so choose this. Now keep it here, double click on it, and I want this one Y grounded, and here the voltage definitely would be for 15 volt, frequency 50 hertz, and active power I want 200 e power 3, okay, and the reactive power I want 100 e power 3, and capacitive reactive power I want 0, okay, just click apply and okay. Now I will use some meter here for measuring the current drawn by the load, okay. So for that, this one just copy and paste, okay, double click on it and just rename this labels. So if it is from the load side, so I will write here L, okay, small l, and here also I will keep it a small l, okay. So you can easily understand EABCL and IABCL. So just click OK. Now rotate it by using Control R, and like this you place and make the connection. So okay, little bit different is here. So Control I, okay. Okay, so just we have to rotate this one. Yes. Now connect A to A, B to B, and C to C. Now connect here also A to A, B to B, and C to C. Okay. Now I want to measure this voltage of this one and voltage of this one also. Okay. So I will take one from block. Okay. So write from and choose it. Okay. Double click on it and write here EABC. Okay. Automatically it will be connected here. Similarly, for the current also we want to measure. So just double click on it, copy paste and double click, rename here. Okay, IABC. Okay, take one scope, connect it, again connect it like this, double click on it, and here you have to choose to view port. Okay. Now I want to see, so for simplicity, I'm just taking here 0.3, okay, simulation time. So the waveform will be visualized better way. So you can see your waveform should be like this. Okay. So if you want to see the maximum amplitude, okay, so peak of this waveforms, so you can take this one and it will be enabled. Just wait. Yes. So you can see here what is the peak value. So 3.38 e power 2. That means okay, so you can see, okay, this much is the peak. 338.8. Okay. Okay, so now I want to use one STATCOM. You know, the STATCOM is nothing but the power electronics equipment will be there. So one inverter, okay, we should have one inverter, and we should have one capacitor, okay, at the input of the inverter, means at the DC link side of the inverter. So for the inverter, we will take universal bridge. So search for universal bridge, okay, and take it from the specialized power system library, okay. So this is the universal bridge. So keep it here and double click on it. Choose here instead of thyristor, make it IGBT diode, okay, apply and connect. So this will be connected here. So okay, before connecting, I'll let it. Now here I want to use the capacitor. So search for RLC branch, okay, search RLC branch from the specialized power system library, okay. So rotate it and double click here, make it RC, okay. This capacitance value, make it 5600, and here 1 e power minus 6, okay, small capacitance. Just apply and click OK. Now connect here, okay. Now this side voltage also I want to measure. So for that, just copy it and paste here and just flip it. Okay, and connect A to A, B to B, and C to C. Okay, and now connect like this. Okay, now this inverter will have some filter we have to use here. So I'm going to use here LCL filter. Okay, so for LCL filter, we will require some inductor, capacitor, and inductor. So just take this RLC branch, double click on it, and make it only L, okay, inductive, and here make it 6. Okay, so here take 300 e power minus 6, okay, and place it like this, copy and paste, okay, again copy and paste, okay. Now I will keep all this little bit away so that easily we can have our capacitor bank here. So copy and paste it here, rotate it, okay, double click on it, make it capacitor C, okay, and this value make it 100 e power minus 6, copy and paste 2 times and make the connection. So it will be connected here, this one here, here. So just finish the connection. Okay. Now copy and paste all these 3 together in this place. Check whether it is connected well or not. Okay. Give this value to 500 or minus 6. Again, copy and paste this all, apply, and re-evaluate all these other inductors. Okay, so Actually, this part is your STATCOM in this case. Okay, so I will write here. This is the area. So you can hear STATCOM. Okay, this belongs to STATCOM. Okay, but in this much is your LCL filter. So better to write here LCL filter. Okay, I will keep it a little bit smaller, and this part is our STATCOM. Okay, so this is your STATCOM. Okay, now I will use one voltmeter here. So just search for voltage measurement. This one. Okay, place here. Let's connect here, and later I want to use this one. Okay, but before that I also want to use this one as for scope. So I will connect one scope here. Okay, and I will take one go-to. Okay, and connect it. Rename this one PC. Okay, make it local only because inside any subsystem I don't want to use. So now you can see that plant the model is complete. Okay, so later stage we will make the controller. So